Okay, so 27, we have these two forces. So really the question I need to figure out here is, what is the sum of the forces? What do I get when I add these force vectors together? So really it's just a vector problem. So for part A, they're giving me numbers. Looks like it's 10 and 16. Why would they make that a decimal? I mean, really. So then I take this one and I slide it, and my new vector is right there. Right? So now I can do Pythagorean theorem here and get 10.2 squared plus 16 squared, square root the whole thing. I'm getting 19 basically. 18.97 is what I got. The angle there is going to be tangent inverse of 16 divided by 10.2, which looks like it's 8.5 degrees. So the force, the net force in this case, is the combination of those two forces.
That doesn't sound right, 8.5 degrees. It should be more close to 45.
Because it's 290-degree.
You're right, that doesn't. Let me make sure I'm in degrees. Yeah. Opposite over adjacent. 16 divided by 10.2. Tangent inverse. Oh, yeah, I must have punched it in wrong. Thank you. I'm getting 57.5. Let's call it 58. Good catch. Okay, so the net force is 19 degrees at, or I'm sorry, 19 newtons at 58 degrees, and we are, you know, below negative x-axis. Now, I don't know that we have to really say that at this point, but we can. They're asking us to find the acceleration here. So acceleration is net force divided by mass. And the mass is 27 kilograms in the problem. So I'm just going 19 newtons divided by 27 kilograms. And that's 0.7 meters per second squared at the same direction as the net force. Because whatever direction the net force is, that's the direction of the acceleration. 58 degrees below negative x-axis. Okay, part B, that's the trickier one. That's probably the one you really had the question about anyway. Let's see, F2 is 16, right? And F1 looks something like this. That is 120 degrees, which tells me that this must be 30. Am I doing that right? That one's 10.2 newtons. So I need to add these together, but I need to split this vector up first into components. So I'm going to redraw a little bigger, enlarge to show actual texture. A few people caught that. Nice, thank you. So let's call this the force in the x and the force in the y. So right, we go 10.2 times the sine of 30, and that is 5.1 newtons for this guy. And we go 10.2 times the cosine of 30, and we get 8.8 newtons for this guy. Which means my total force then is, notice this one and this one are in opposite directions. So I need to subtract for the sum of the forces in the y direction. I've got to go 16 newtons upward minus the 5.1 newtons downward. Or you could call this the resultant in the y, is what we were calling it when we were doing vectors. Which is, what, 8.9? No. Sorry. How about 10.9? Is that right? That sounds better, doesn't it?
Yes.
And then we can do the sum of the forces in the x direction, or call it resultant in the x, either one. And that is only the 8.8 because there's no other one in that case. Which tells me that we are going up 10.9 and we are going over 8.8. Didn't draw this to scale, did I? And the resultant looks something like this. So adding those two together is giving me something that's in this direction, you know, and kind of that size. That's what this guy is. Because part of it cancels part of that, and nothing cancels the sideways. So then we can find the net force, which is 10.9 squared plus 8.8 squared. Square root it, and we get 14 newtons. So the acceleration is 14 newtons divided by the same 27 kilograms. Getting 0.52 meters per second squared. And we still need an angle here, which I didn't figure out. Tangent inverse of 10.9 over 8.8. 9.6, does that sound right? I don't think so. 10.9 divided by 8.8. 51 degrees, that sounds better. At 51 degrees, and this angle is above positive x-axis. Like that. Questions on that one?
It wants acceleration.
It wants what?
Acceleration.
Yeah, isn't that the acceleration? 14 divided by 27?
Oh, I zoned out for a second, I'm sorry.
It's okay, I do it too.